Hi, good afternoon, folks, and thank you for attending this session on smart cities, how to implement a smart city solution with the intelligent cloud and edge. So my name is Janakar Angama. I'm a senior principal product technologist for the intelligent edge team at Dell EMC. So I'm a regional product technologist for Asia Pacific, Japan, and China. A little bit about myself. I'm a Sri Lankan, born in Sri Lanka, and now living in Australia. So I'm a Lankan Aussie, 5 times Microsoft MVP, a Microsoft certified trainer, and I run a couple of user groups in Sri Lanka and Australia as well. And if you want to get connected with me, my details are there. And I've got an upcoming book with a couple of other MVPs on Azure Kubernetes Service, an intro to the managed Kubernetes service on Azure. So it's available to pre-order now. So if you want to take a look on that, feel free to do so. So before starting the session, can I ask a question? How many of you are new to IoT? Oh, there's a few. How many of you are currently working in IoT? Yeah. How many of you are in are developers? Okay, cool. So the goal today in this session is to have a idea about the whole IoT and edge solution ecosystem throughout Azure by running through a use case. So all these slides and the workshop for this particular session is available on GitHub. So it's a Microsoft resource readily available. So when you go back from this session, you can literally try it out if you have an Azure subscription. So I'm going to run through this scenario and going to discuss a few key points about designing a smart city solution using the Azure services. Everybody loves New York, right? So the New York City Council has this requirement where they need to design an IoT solution for their transportation system. So there are a couple of boroughs that still use uses the buses as the transportation system. So basically what they're looking at is to develop a centralized IoT management solution where they want to add devices, IoT devices to buses so that they can collect data for preventive maintenance and driver performance. So driver performance in the sense like if a driver is driving too slow at a traffic light, that's fine, but what if he's just going through a red light? Those kind of data they want to gather. And another requirement they had here is that, in a solution like this, you can't always rely on internet, right? Because this is an edge solution. You might drop into dead zones, and the cellular reception might be low. So they want to analyze data locally first, and whatever data that the solution cannot determine or transform to information, or we call it the anomalies, to be sent to the cloud for further analysis. That's a requirement, right? So on-demand analysis. And of course, in a solution like this, you have to rely on GPS to pull the location data. So to determine the speed and the location of the buses, they want to periodically send the GPS data. And another key piece of this solution is the traffic light themselves. So you get location data plus the driver performance data from the bus speed and things like that. And then you want to see how the traffic lights are performing. For an example, back where I'm from, originally grew up, Sri Lanka, we have traffic lights in major cities, right? I'd say the pedestrians almost get 10 seconds to cross over, but the drivers they would just take the first 5 seconds of the green light as well. So literally 5 seconds. That should not have happened, right? So in order to avoid situations like that, they want to collect the data from the traffic lights to determine if there are any performance issues. So if a traffic light, the time between a red and a green is too big, they want to determine things like that as well. Also, Now, another goal of this system would be to keep this traffic light system up to date. They want to use the same device, IoT edge devices that are on the traffic lights, to issue the update commands to the traffic light system. And later in the session, we are going to discuss what are the challenges they see when doing that. And finally, using all this data combined together, they want to analyze the traffic congestion near lights from the data they receive from the traffic lights, buses, and the GPS data as well. Now, this is the whole scenario that we are going to discuss through. Now, every solution has key requirements like from the customer, right? So the customer is New York City Council. So their end goals are pretty much simple. They want to reduce the bus maintenance costs, basically by analyzing the telemetry and applying predictive analysis provided by using a trained machine learning model. So in a solution like this, yes, you are using IoT edge devices, but you are not always connected to the internet. So that means the algorithm or the machine learning model you use should be able to be deployed in a edge device. So that's their first requirement. Now the second requirement is to detect anomalies, and those anomalies should be sent right away when they have a connection. So basically, they don't want to send off all the data. They want to filter the data and send only the anomalies to the cloud. And the third requirement is regularly send the GPS data in a periodic interval so that they know what are the updated bus routes and the traffic conditions. And another one is they want to add IoT devices to the lights themselves so that they can update the traffic lights and gather data from the traffic lights as well. Now, all this data runs through a time series, right? So they want to know 8 a.m., 10 a.m., 12 p.m., what's the traffic congestion would look like. Are the traffic lights performing perfectly, right? What's the driver performance like? What's the driver driving behavior? So they want to analyze this over a period of time. And finally, now, doesn't matter how you gather this data. You can gather data any way you want. Like you have all those devices running up. How do we present this data? So basically, shall we use a mobile app where the users can see how fast they are moving and whether there are any issues? Or shall we give them a web portal for the people behind the desks to analyze this data? Those are some of those requirements they have, right? So the fine print behind the whole solution is, if you drill down all these requirements and see the key three objectives that they want to achieve, is that they need an easy way to capture and analyze this time series data for all the IoT devices. So if there are 5,000 buses, 5,000 traffic lights, and the GPS data as well, so they need to analyze find an easy way to analyze these. So another thing is they need to automatically handle the schema changes. If there are new IoT devices coming up, right, they want to update and push those software that they're using as well. And sometimes they don't want to do this all at once. For an example, if there are 10 buses in the same route and 10 buses in a different route, they want to update these software like one route at a time, things like that. And finally, the presentation layer of their solution. Now, this is the solution architecture for this solution. So there are a number of things in this solution architecture. I'm going to explain how all of these connect together so that this solution can be used to effectively monitor your traffic conditions, so basically New York City. And what are some of the key points of this solution that the developers should be focusing on, right? Like I said, this particular demo or the solution is available on GitHub. I have put a link on my slide deck. Feel free to download that from GitHub and try it one out. So pretty easy, uses Power BI, uses some of the other components for presentation layer, and easy to set up as well. So if you ever come across a solution where you need a pre-baked solution to present to your customer, it's all available. Now, if you see how this solution starts, the first part of this solution is with the IoT edge devices installed in each bus. So this edge device actually reads the vehicle telemetry data, like the speed, the fuel level based on the speed they're going, and the engine temperature, whatever telemetry data it can capture. Second part of the solution would be for that IoT device to work, it needs an algorithm to work. So the algorithm would be a trained Azure machine learning algorithm. So what this algorithm does is, it has an actual a predictive maintenance module which uses the data gathered by that bus, the edge device in the bus, to predict and detect any anomalies of the telemetry data it's getting, and maybe potential issues. For an example, if the driver brakes too much, right, put pressure on brakes too much, it should be able to detect that as an anomaly and maybe report as an engine alert or something like that back to HQ. Now the third step would be adding something called an Azure Stream Analytics module, which can filter the output from the predictive maintenance module that we have deployed and send only those anomaly data to the cloud to analyze. Now then we have the GPS device where it periodically sends the location and the speed data to an IoT hub. So this GPS device is separate from the IoT edge device. So all it does is sending the GPS data periodically. And for the traffic lights, there's a separate IoT device. It reads telemetry like voltage readings. For an example, if a light is on, there should be one voltage state. If the light is off, there should be no voltage at all, right? So based on those binary data, it should be able to detect things like, for an example, if we register the IoT device connected to a traffic light, it should be able to gather the serial number, the location, and all this stuff. So for an example, if I'm not getting any readings from a particular traffic light, I should be able to pull those data, like the serial number and stuff like that, should be able to dispatch a technician to have a look. Another thing it can do is to receive cloud-to-device data from the IoT hub. So IoT hub, in this sense, is the central, like the location where you receive the data and push the data back again, so that it can learn about the timings of lightning. So basically, what's the time interval between two lights, red or yellow to green, stuff like that. So, and couple of other components in this solution architecture would be the time series insight instance and the stream analytics instance we discussed earlier. So these actually work together to read the incoming data. So the stream analytics instance that we discussed actually filter the data from the edge devices, right? So let's see the functionality and the expectations from each of these components and see how they work together. Now, what do we expect from the IoT devices? So we use the IoT hub to manage the devices. So IoT hub is able to push all those updates and read data back from those devices. And the IoT edge devices are able to process the vehicle telemetry data locally, detect anomalies, store data offline, and send only the anomalies or the important data to the cloud. And the GPS devices, like we discussed, sends the data separately, GPS data, back to the cloud. And finally, the IoT devices use custom endpoints and routes in the IoT hub. It filters what is critical, and it filters what is non-critical, so that these data can be ingested to a service bus queue. The service bus queue will move the data back and forth. So what about data and visualization? Now, we are using a couple of components here. We are using the Azure time series, and we are using a Cosmos DB to store reference data. And then, like we discussed earlier, one of the major goals was the presentation. So we'll be using a custom web app, which kind of like pulls all this data together and provide the presentation layer. And furthermore, if you really want to have like end users to participate in this solution, you can easily provide a mobile app that pulls data from that the APIs that are provided by the app service, or you can use Power BI for the reporting behind for the HQ. So what about the location-based data and mapping? So in this solution, for the location services, we are using the Azure location-based services, right? And this service is a part of Azure, so it actually supports all the compliance, privacy, and data sovereignty methods that are available in Azure. And like I mentioned, now I've got like a 20-minute session, so I really don't have time to go through all the nuts and bolts of this solution. Take a look at this link, right? So see, all these information are available in this link. You can try this one, this solution. So the way this solution works is, it actually starts something called the IoT accelerator as the base to start with. And on top of that, we are creating deploying a Visual Studio solution to simulate this vehicle telemetry data, right? So you can the same solution accelerator you can use for some other stuff like that, predictive monitoring. So you can use the same algorithm for like temperature readings and something like that if your solution into manufacturing. So if you go to this link, you should be able to get the accelerator information, and all you need is an Azure account to start this with. Let's take a look at some of the customer objections. Now, like I mentioned, this is the time series data that we are collecting, and how do we make sure the data is synchronized in the order they are received, even they are offline, right? So in order to ensure that's happening, what we do is we use the device's message created value for the time series inside, basically the timestamp data, to process them in order. Then another question would be, right? Now, rolling updates. Like I mentioned, I have 1,000 buses. I don't want to deploy this to all 1,000 devices. How do I make sure that I deploy these in batches? So in this IoT edge, there's something called the fleet management. So you can create fleets, fleet 1 to n, based on the routes. So if you are pushing the update to fleet 1, it will go only to the devices that are registered under fleet 1, right? So these are some of the common concerns that the city council had when they implemented this solution. So if I go back again, this whole solution is contained in something called the MicrosoftCloudWorkshop.com, right? There are a bunch of demonstrations, exercises available, not just IoT, in the whole solutions or the service available in Azure. I highly recommend you to have a look on those and get a look and feel about what's available. So yeah, I'm almost on time, and if you have any questions, I'll be here. Yeah, thank you for attending this session. Thank you.